In 1980, 3 siblings were each given $1,000 as part of an inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. Now, this is sad to me because are they not talking the whole rest of the time? I don't know. I would hope that your siblings and you would talk because, they're friends and stuff. So let's talk about the siblings, okay? Not behind their back, just in general. Okay. The oldest brother, Alan, put the $1,000 into the bank. Each month, he would add $62.50 to the account, or $750 per year. The sister, Bernice, or Bernice, as they called her second period, invested her $1,000 in various money market accounts and earned 12% interest each year, which was compounded annually. Carl, the youngest, put his money into technology stocks. Their value climbed according to a parabola curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to the original value of $1,000. That's very sad. Okay? So first things first. Number 1, we need to determine which sibling's financial history matches each of these graphs above. Then how can you tell? Okay? So which person goes with which graph? So C is the one that goes woo. Okay? So that's Carl's, right? So Carl is which one? What is it also called besides the umbrella thing? Oh, parabola. So Carl is the parabola. Now, how can you tell? It's not good enough to just say Carl's a parabola. How can we tell? So he started low, it went high, and then he came back low. Okay? Is that what you want me to write? We can use some better math vocabulary than that, can't we? Okay. So his money increased and then decreased. Guys, another thing is it says it's a parabolic curve. For the record. Right there. Okay? Alright, so we know about Carl. We still have Alan and Bernice. What do you think? Alan is the linear? Or Alan is the line? We could say Alan's is linear, or we could say Alan is the line, but we don't want to say Alan is the linear. Okay, I already wrote is the, so is it okay if I put line? Okay, but if I spell it right, that would be better. Okay, Alan is the line. How do we know that? His money increases at a, what'd you say? Steady rate. What's another word that we can use instead of steady? That would be more mathematically correct. Constant. Now, steady is not wrong. Please understand that. That's why I left it in there. Okay? But when we used vocabulary, our math vocabulary, when we were talking about lines, we talked about a constant increase. Something like that. Okay? So, which leaves what? Bernice? Bernice. Okay, Bernice is the last one. Okay, what is the last one?
Is it a logarithm? No. It's like a negative or
It is. Isn't it exponential? Starts here and goes. How do we know that? Her money. Her money. I did not say Armani. Her money is earning. Not earring. Earning interest each year. Okay. Here we're going to let x equal time in years since 1980. We need to write function rules for each one of these siblings. Which one of these do you think is going to be the easiest to write? Alan? Because it's just a line. Okay? So what's the parent function then of Alan's? What is it? mx plus b. M being the slope, b being the y-intercept. Now when we're talking about word problems like this, we don't really talk about slope as much as we talk about our rate, right? Our rate of change. So do we know all of this stuff that we need to for Alan's equation? Well, it already has the a of x equals, so we don't need to write e equals, or y equals. What's m in Alan's case? It would be 6250 if we were talking about months. But remember, it tells us right here, we got to talk about years, right? So 750 x y 1,000. That's where he started. That's perfect. I am also hungry, but can we talk about that later? Okay. So which one's going to be easiest next, Bernice or Carl? Probably Bernice, right? What parent function are we going to use for Bernice? Something with an exponent, right? We talked about several different formulas. I think it's the roof people again. I'm sorry. We talked about several different formulas when we're compounding. This is being compounded annually, so it's not anything with an E in it. Okay? We talked about that formula. Do you remember that?
Yes.
But if we're compounding it annually, what is our N in these problems? How many times a year is it getting compounded if it's getting compounded annually? Once, right? Once. So I'm dividing by 1 and I'm multiplying by 1. So the formula we actually need to use is y or a equals p times 1 plus r to the t power. Do you remember dealing with that formula? Yes, good. Do we know everything we need to know for this formula to write Bernice's equation? Okay, so tell me what it should be. 1,000 because that's what she started with. 1 plus her rate, 0.12. So what is 1 plus 0.12? 1.12. Raised to what power? Guys, look. T, except it asks us to use x. You okay with that? That was just last chapter, so I was hoping you guys would remember that. Do you remember it? Ish. Okay. Now we have Carl. Now Carl's going to take a little bit of work because why? He went up, then he went down. This is a parabola, right? Okay. If parabola is what the graph looks like, what is the parent function called? Oh, shucks. I'll give you a hint. It starts with a Q. Quadratic. Oh, quadratic. Okay, good. I'm glad you remember that. Excuse me. I'm going to get out some scratch paper so we can do some work on the side, just so you know. You might have enough room to write this in this area right here, but I know that I don't. So I'm going to get out some scratch paper. Okay? So I'm going to look back up here to the sentences, to the explanation, what it tells me about Carl. How many points do I need to be able to write the equation of a line? Just 2, right? How many points do I need in order to write the equation of a parabola? I need 3. That's exactly right. Yeah, I need 3, okay? Looking at the information about Carl, do I have 3 points? Can you tell me what they are? So where he starts at 1,000, in the middle at 20,600, and then at the end 1,000, right? Do I have enough information to write those as ordered pairs? What is my x value? It's time, right? Okay, time in years. So what's my first x value? My first x value? 1980. So that's 0, right? Because we're talking about time since 1980. So wouldn't that make sense that my time was 0? Okay. And how much money did he have in 1980? $1,000. Okay. From that information that I just gave you, can you tell me the second value, the second ordered pair? Whoa, whoa, whoa. Nowhere in this problem does it say 14. Oh, so 1994 is 14 years since 1980? Oh, very good. 14, 20,600, right? So what's the last ordered pair? Somebody else. It's okay. I can tell people are working on this. So I'm not upset.
14 again? Is it 28?
It is 28. Why is it 28? 2008? From 1980 to 2008, that is 28 years, right? So 28 years since 1980, he's back at 1,000. So here is what you need to remember. I know some of you have trouble remembering what you had for lunch yesterday. So is it okay if I walk you through how to write the equation of a parabola from 3 points? Okay? Everybody's okay with that? All right, here's what I want to start with. Why do I want to start with this? That's the standard form of a parabola, right? Or of a quadratic equation, quadratic function. Well, do I know an x and a y? And an x and a y and an x and a y? So my goal here is to get 3 different equations from each of these different points. So first of all, I'm going to ignore the second 2 points and just look at the first point. If this is my x and this is my y, let's plug it in everywhere that there's an x and a y. So what happens right here? What is 0 squared? 0 squared is 0 times a is just 0, right? Okay, so there's nothing there. What about here? 0 times b? Nothing. And then what goes here? Oh, c equals what? 1,000. Now, why didn't I say 0 times c? There's no x, right? So I just have c. That's all I have. Okay? So what about the second point? Let's ignore the first point and the third point and just look at the second point. What do I do with the 14? Put it in the x, right? So what is 14 squared? That's a good idea. Yet if you don't know off the top of your head, shouldn't you put it in the calculator? Or multiply it out by hand? 196a. Right? 196a? Plus what? That's exactly right. 14b. Plus what? C equals what? 20,600. Now, these 2 equations look different. Does that mean one of them's wrong? No, we did everything right. We started with a 0. Okay? Now, Last point. So far, this equation, or that point's going with that equation, this point's going with that equation, so we're going to write the third equation right there. Okay? What do you think? What do I do with the 28? Square it. What is 28 squared? Put it in your calculator. 784? 784 what? A plus 28b plus c equals 1,000. I now have three equations with three variables. I know the first equation I only have one, but you get the idea, right? It's really 0a plus 0b. Anybody remember how we solved a system of equations with three variables and three equations? I did a matrix, right? We did a matrix. So I'm going to start a new document that is a calculator. And I'm going to say menu, matrix, number 7. What am I going to choose first? Reduced row echelon form. Yeah, reduced row echelon form. That's number 5. Okay? So, do you remember this now? Is it coming back to you? So now that I have RREF there, now I need to go menu, matrix again. Now what? Nope, I already did that. Now I got to create the matrix, right? So let's create the matrix. Create the matrix. How many rows does this have? How many rows does this have? Watch my finger. 1, 2, 3. 3. Tab. How many columns does this have? 4 columns. Remember to use tab in between, otherwise if you try to use arrows, it'll take the number up and down. Now, does that look like what I need it to look like? So that's a pretty good indication that I got it right, right? So start me off. Tell me what to put in here. 0, tab, 0, tab, 1, tab, 1,000. Now you can use the arrows here, but if I hit tab, it's going to take me to the next one. I don't have to do a whole bunch of arrowing. Okay? 196, tab. Very good. Excellent. Tab. 784. Oh, thank you. Good catch. Sometimes I just get excited with the zeros. Is that better? Thank you for catching that. 28. 1. 1,000. Now what? Enter. Did it tell me anything? Oh yeah, it told me exactly what I needed, right? What was I trying to solve for in this system? What are my variables in this system? A, B, and C, right? So look at your calculator and tell me what A equals. Negative 100, yep. What about B? 2,800. What about C? 1,000. Did we already have an idea that C equals 1,000?
Yes.
From that, right?
Yes.
Okay, so we're good. Now all that's left is to write the equation. Well, all I have to do is go back up here, don't I? Now, on my worksheet, it's already C of x equals. We're trying to fill it in, so we don't need to add this y on the end, do we? Okay? So write my equation for me. Using that as my model, using this as my information, what's my equation? Negative 100x squared plus 2,800 x plus 1,000. Perfect. Now, hopefully you wrote that in your spot on your worksheet. I just wrote it on the work that we had to begin with so that I would have it. I'm going to transfer it to my worksheet, making sure I don't put too many zeros. All right, we okay so far? Okay, so, Now, check the equations using a graphing calculator and a domain of 0 to 28. So, I'm going to add a page that is a graph, and I'm going to put all three of these equations in. 750x plus 1,000. Tab. 1,000. Whoa. 1,000 times 1.12 raised to the x. Tab. Negative 100x squared plus 2,800x plus 1,000 . Now, what does this mean right here with the domain of 0 to 28? Does it tell me what window to use? Oh, yeah, okay. Menu, window, my Windows settings. For my X values, I need to go from 0 to 28. Okay? So what about my Y values? Well, could we look at the graph they already gave us? It's probably a good idea, right? So 0, what is that, 20,000? Now, we know that this one goes to 20,600. So are you guys okay with me going to 21,000? Okay. Does my graph look like that? So do you think we did it right? Okay. Use the functions to complete the table. Well, that's what's nice about these calculators. Once I have that in there, can't I just go Control T? There's my table. Let's copy down the information. Okay. Let's copy down Alan's information first because we have him in there at F1, right? F1 should be Alan's information. Did everybody catch the fact that Alan is A sub x, Bernice is B of x, and Carl is C of x? Okay, just checking. So after 5 years, Alan is at 4,750. After 10 years, 8,500. After 20 years, 16,000. And then after 25 years, 19,750. Do you guys get that same thing? So what about Bernice? Where should she be? If Alan was in F1, where is Bernice? F2? Okay, well, I'm going to go backwards because I'm already down here at the bottom at 25 years. Are you okay with that? 17,006. Now, some of you are going to argue with me and say it's 17,010. But when that's highlighted, this is giving me the exact value of that table. So do you see that it's 6 cents on your calculator? Okay. So then I need 20. And at 20, it's $9,646.29. And then back to 10. 3,100, whoops, and $5.85. And then to 5, $1,762.34. So where should Carl's money be? F3. I'm going to scoot over one more time. After 5 years, he had $12,500. After 10 years, he had $19,000. And then at 20 years, he had $17,000. And then at 25 years, $8,500. So, look this way across the table now. After 5 years, who had the most money? Carl. After 10 years, who had the most money? Carl. After 20 years, who had the most money? Carl. And after 25 years, who had the most money? Alan. Okay? Okay so far? Yes? It is given that Carl had $1,000 after 28 years, so how much did the other siblings have at this point? How much did Alan have at this point? Guys, can I still just use my calculator for this? Alan is an F1. All I need to do is go down to 28. How much did he have? $22,000. And how much did Bernice have? $23,883.87. Use the graph on the calculator to answer these questions. After approximately how many years did Alan and Bernice have the same amount of money? I'm going to press Control T to get the table to go away so we can just be looking at the graph. How can I figure this out just by looking? Oh yeah, intersections. Okay, so which one is Alan's? The line. And which one is Bernice's? So here's what we're going to have to do, because watch. Menu, analyze the intersection. It's asking me, which graphs are you talking about? So I'm talking about the line and the exponential, right? So here's the deal. It's up there. Can we see it? So it might get mad at that, but watch what it does. Lower bound on the left side, right there. Upper bound on the right side. What did it do? Did you see what it did? It changed its window. Okay? So the point of intersection says 27, 2.12 E4. So we need to interpret that as mathematicians. What does that mean? At 27 years, they each had how much money? Starts with that, right? Times 10 to the fourth power. This is where the decimal is. If I'm multiplying it times to the fourth power, 10 to the fourth power, I say 1, 2, 3, 4. I need 2 more zeros right there, don't I? So how much do they have at the end of 27 years? $21,200. After how many years did Alan and Carl have the same amount of money? Now we have to do it again, right? So go back to your calculator. Which one is Alan? So I'm talking about the line and the parabola. So I want to put it right there, our left bound and our right bound right there. Now that's kind of hard to see, so I'm going to grab it and move it up here so we can see it a little easier. Okay, so the point of intersection says 20.5, 1.64 E4. I'm going to keep doing 6 and 7 so that you have it on the recording. Number 8, ask you to solve it algebraically, which means you're going to figure out which ones you can solve algebraically and actually solve it algebraically. You already know the answer because we're going to figure out the answer when we do it in the calculator. Okay? This means at 20.5 years, they each had 164 times 10 to the fourth, 1, 2, 3, 4, so 16,400. Last but not least, Bernice and Carl. Bernice is the exponential and Carl is the parabola. So menu analyze, intersection. I'm talking about the exponential and the parabola. So the point of intersection is going to be that point right there. So I'm going to put that on the left and that on the right. And it gives me this value right here, which I'm going to move so we can see a little bit easier. So that says 22.7, 1.31 e plus 4. So that means 1.31 times 10 to the fourth. So at 22.7 years, they each had 131 times 10 to the fourth. So 1, 2, 3, 4. So $13,100. Now, you're going to have to be careful which ones you solve algebraically, because this one, Bernice's equation, has my variable in my exponent. And while we know how to get variables out of the exponents to solve, we don't know what to do if there's also a variable on the other side of the equal sign. Okay? So if you can't use Bernice, who are the two that you're going to be able to use? Alan and Carl. Okay? So we're going to say Alan and Carl. Well, if we're trying to solve them algebraically, how are we going to solve them? If we have two equations and we're trying to figure out when did they have the same amount of money, I could use the table. It might be a little messy. If they both equal an A of x or B of x or C of x, shouldn't they equal each other if I'm trying to figure out when they're equal? Okay, so Alan is 750x plus 1,000, and Carl is negative 100x squared plus 2,800x plus 1,000. That's just a quadratic equation that we solved many, many times in class. So just solve this one, subtract 1,000 from each side. That'll get that to go away. Get all your x's together. See if you can factor out something common. And then solve for x. You want me to keep going? Okay. So subtract 1,000. 750x equals negative 100x squared plus 2,800x. It's quadratic, so what do I want to get it to equal? 0, right? So let's subtract 7,500 or 750x from both sides. Negative 100x squared plus 2,150x. Now, there's a lot of stuff that's common that we could factor out, but for sure an x is, right? Okay, so if I factor out an x, like I said, there's more stuff we can factor out than just x, but time's not on our side right now, so I'm just trying to hustle. Okay, whoop, that's not a square, that's just an x. So if I have this and that equals 0, what's true about one of these two? At least one of them has to equal 0, right? So I'm going to say x equals 0. And I'm going to say negative 100x plus 2,150 equals 0. That's already solved. I'm going to subtract 2,150 from both sides. Is it 2050? Thank you. Sorry about that. 2050. So negative 100x equals negative 2050. Dividing both sides by negative 100, x equals 20.5. So here's what's cool. Are you ready? Look back up here when we did Alan and Carl. What did we get our x value as? 20.5, so I know I did it right. How am I going to find the y value if I know the x is 20.5? Put it into this equation or that equation to figure out what y is. Does that make sense? Guess what it's going to be when you put it in? Yeah, 16,400. Okay? Got it? Peace.